Hello everyone, welcome back to another episode of my custom dimension series. Last episode we took a look at these custom biomes right here. As you can see, we've got the red forest, the yellow forest, and the blue forest. But it's time today to address the elephant in the room, which is that none of these forests look like forests at all. They're completely empty, and obviously the reason for that is that there are no trees in the forest. So in this video we're going to be taking an in-depth look at features in Minecraft, and we'll be able to define different features for each biome. And with features, we'll be able to generate things like trees, rocks, or anything else that might appear in a forest. So with that, let's go ahead and get into it. All right, so let's go ahead and get started with our feature here. And to start, there's two files we'll need. Inside our Worldgen, let's create a new folder called configured feature. And in here, we'll create our configured feature file, and let's call it redtree.json. Now this is a map with a type that we can choose. And there are a few options that we have, including Minecraft tree, but we're not going to define a tree just yet. We're going to do something a little simpler, Minecraft simple block. All this will do is place a single block wherever this feature is generated. But now that we've defined the type, we can also define config. And this is where our configuration for this type lives. So each of these types has a different set of configuration options. The simple block simply has to place, and this is simply a block state provider, which means we provide a type, and there's a few different types which these simply allow you to vary the block based on random conditions. However, we just want a single simple block, so we will say simple state provider. And now that we've chosen this, we also get the state field, which is a block state. That means we provide a name, for example, Minecraft basalt. And with that, our configured feature is done. Next, we need to define a placed feature. So the configured feature, as you can see, defines what is placed. However, the placed feature defines where this feature is going to be placed in the world. So let's create a new folder in Worldgen called placed feature, and we'll create a redtree.json in here. This time we select a feature. This references the configured feature that we want to use. In this case, my data pack red tree. Next, we need to define the actual placement using the key placement. And this is an array, and it will go through these placement rules in order. So each placement rule we define. So by default, if we didn't have any placement rules, it would place one feature at the origin of each chunk. However, that's not in a very helpful place because it's actually all the way at 0, 0, 0 in each chunk. That's underground, and it's very evenly spaced. There's no random spacing to it at all. So we don't want that. So let's just go ahead and add a placement rule with a type of height map, and we can define what height map we want to use. Let's use world surface Worldgen. We're in the Worldgen step, so we can use this right now. And for now, this is all we'll define in our placement field right here. In the future, we'll define other things to, for example, increase or decrease the number of these features that are placed, or we can randomly move these about to create a more natural looking generation. But for now, let's go ahead and add this placed feature into our biome. So for our biome, red forest, inside of features, we'll add another subarray here, and we'll say my data pack red tree. The reason we have this subarray is because each subarray goes in order during the world generation phase. So it'll generate these first, then it'll generate any in here, and then it'll generate any in here, and so on down the list. And this gives you a lot more advanced control, especially once you get a lot of features and they start to overlap and things like that. For now, we've just got one feature, so we'll just have one subarray. Let's go ahead and delete our dimension file here and go back to Minecraft. And if we look down here in our red forest, you can see evenly spaced around are these basalt blocks. Now, as you can see, one interesting phenomenon is that they do generate a little bit outside the range of the biome we defined them in. So in order to fix this, we actually need to add a new placed feature rule. And this is very simple. It's got a type of biome, and this is actually all we need in this one. There are no additional fields. So now if we go back and delete our dimension in Minecraft, you can see now they only generate inside this biome. And now would be a good time to explain how these placement rules actually work. It actually goes in order of this array, and it applies the specified transformations to the feature. So like I said, they start at 0, 0, 0 in each chunk, and this rule is a type of height map. This modifies the y coordinate to match the height map world surface Worldgen at whatever coordinate the feature is. Then this biome placement rule filters out any placements that are outside the biome that is specified. Now another way we can filter these out is to use a rarity filter. And just by convention, we'll place this at the very beginning. And this type of rarity filter gets a chance, and we can set how much we want to filter out. I'm going to set this to 8, for example, and this means that 1 in every 8 features will be kept, whereas the remaining 7/8 will be thrown away. And this results in the feature being just a little bit more rare. So let's go ahead and hop back into Minecraft. And now we'll notice that the basalt blocks are not everywhere. They are just a little bit more spaced apart. However, if we go to each one and we use our F3 screen right here, we'll notice that the block inside the chunk is always at 0, 0. If we go to another one, we can see it's at 0, 0. Find another one, 0, 0. This is because, like I said, they start at 0, 0 in the chunk, and we're actually never changing the X and Y coordinate of the feature. So let's go ahead and do that. We need to make sure this is before the height map, because we want the height map to apply to the new coordinate rather than the old coordinate. If the new coordinate, for example, is higher up and we apply the height map first, well, then the feature would be generated too low because the height map was already applied before we moved it in the X and Z directions. So let's go ahead and add before height map a type of n square. The n square type simply moves the feature to a random position within the chunk it's generated in. So now that we're back in Minecraft, let's look at the F3 screen, and we can see this one's at 5, 10 in the chunk. This one's at 12, 14 in the chunk. And this one's at 2, 0 in the chunk. So I think you get the picture. Each of these are now more randomly spaced. And if we fly up high and look down at the ground, you'll probably notice, if you can see those all the way down there, that they are, in fact, more randomly spaced. Now, what if instead of limiting the number that we have through this rarity filter, we wanted to increase the number of features that we generate within each chunk? So we can do this by changing rarity filter to count. And count gets a key instead of chance of count. So this will generate 8 features within each chunk. Then it will move them randomly within the chunk that they're in. Then it will move them up to the surface, and it will make sure that now, after doing all that, they are still in the biome that we want them to be. And now you can see we've got a lot more basalt blocks around, and you can see they're all randomly placed within each chunk. And this looks like a pretty nice distribution for a forest if each of these blocks were trees instead of basalt. So let's go ahead and change this configured feature here. Instead of Minecraft simple block, we'll make this Minecraft tree. And obviously our configuration is going to be much different, so let's clear this out. And you'll see there are a lot of things we need to define. Let's start by defining minimum size. Now this minimum size is actually an object that defines how much room the tree needs to grow. So we'll say type Minecraft 2 layers feature size. That's the simplest one for a short tree like we're going to start with. Then we don't actually need to define anything else, but if you wanted to, you could set limit, lower size, min clipped height, and upper size to choose how big the tree actually is. We're going to leave these values at their default values because that's all we need for this. Next, after the minimum size, we've got a dirt provider, and this defines what block is going to be generated at the bottom of the tree for its dirt block. So for our tree, let's make a new simple state provider. We'll give it a state with a name of Minecraft red glaze terracotta, for example. And this is essentially going to be the root of our tree. Now we need force dirt. And this just determines whether or not it will manually place this dirt provider all the time. We'll set this to true. Now we get into the good stuff. Now we're going to define a trunk provider. This again is a block state provider, and we can give it a state of Minecraft white concrete. Then we get to do the trunk placer. This trunk placer is what determines where the trunk blocks get placed, whereas the trunk provider chooses which block is actually used for the trunk. So for the trunk placer, we can give it a type, and the simplest one is a straight trunk placer. Now we can also say base height. We'll make this 4. This is going to be the minimum height that the tree will be. And then Minecraft will also always add a random value between height rand A and height rand B to the base height of 4. So if we set height rand A to be 0 and height rand B to be 4 as well, the tree will be 4 blocks tall, and then it will pick a random number between 0 and 4 and add that to the base height of 4 to determine the total height of the trunk. This is just for the Minecraft straight trunk placer. There's additional rules for other types of trunk placers as well. Next, we need to do the exact same thing except for the foliage. So we'll say foliage provider, and for our leaves, we'll use maybe red mushroom block. Then we need a foliage placer. We'll give it a type of blob foliage placer. This is the default foliage placer for oak trees. Now I'm just going to run through these different parameters, and then I'll explain what they do a little bit later. We'll set height to 3, offset to 0, and radius to 2. Now the last thing we need to define is called decorators, and this is going to be an empty array because we're not going to have any decorators on this tree. This is how Minecraft adds cocoa beans or vines, etc. onto trees. And now all of this is done. We've got our tree configured feature. And now let's make sure our placed feature is good. We've got 8 per chunk. I'm actually going to change this to 4 per chunk just so they're not too close together. And we're moving them into a random position within each chunk, making sure they are on the surface of the world and making sure they are in the red forest biome as we've defined here. Features my data pack red tree. So if we delete our dimension and head back into our world, ta-da! We've got red mushroom trees using white concrete. And this actually doesn't look bad, does it? But if you look, we've got the white concrete, and underneath here, we've got red glazed terracotta. Like we said to force the dirt, and we set the dirt provider to be red glazed terracotta. So we've got red glazed terracotta underneath all of these trees. And hey, if you're enjoying this video so far, please don't forget to leave a like and subscribe to catch more videos like this in the future. Now I promised I would explain the foliage placer parameters here, and it's a lot easier to explain when you have it in the world. So this height parameter here actually defines the height from the bottom of this all the way up to the top layer here, plus 1. I don't know why there's an additional layer here, but that's just where it starts. And then it adds 3 layers on due to our height. Next, we have offset. This is how high the leaves are going to be offset from the top of the trunk. So we set our offset to 0, so it's exactly 1 block above. But if we set our offset to 2, it would shift the leaves up by 1 block. Finally, we have radius. And this one's probably the simplest to understand because it's just how far out from the trunk the leaves go. All right, now that our red forest is looking pretty nice, let's move on to our blue forest. Let's create a new configured feature, blue tree.json. And for this tree, we're actually not going to use the Minecraft tree type. We're going to use the Minecraft block column, and we'll give it a configuration. We'll start with direction. This determines whether the feature goes up or down. You'll understand what I mean in a second, but let's go ahead and set this to be up. Then we get allowed placement. This is a block predicate. We have to include this, but if we set this to Minecraft true, it will always be allowed to be placed. Next, we have prioritize tip. This is a little bit technical, but it determines whether the tip or the base of the column will be placed when only 1 or fewer blocks can be placed. Finally, we get to the good stuff, layers. This is an array of layers here, and layers have a height. Height represents the number of blocks that this layer will take up. So for our blue tree, I'm going to go ahead and set this to 3. This layer is going to have a provider, and we'll just provide light blue concrete using a simple state provider. Now we can add another layer, and this one's going to have a height of 1, and we're going to use a pearlescent frog light. And with that, our blue tree configured feature is done. Let's go ahead and add a placed feature to match. Bluetree.json, and we'll select our blue tree configured feature. Then we'll define some placement rules. First, we'll set our count. We'll have about 3 per chunk. Then we'll go ahead and randomly position them in the chunk. Then we'll move them up to the world surface using world surface Worldgen. And finally, we'll make sure that they are in the correct biome. Now all we need to do is in our blue forest biome, add a new subarray to features and pass in my data pack blue tree. Now we can hop back into our world and look, we've got our blue trees generating in our blue forest biome, as well as our red trees generating in our red forest biome. Now I really like these trees. They're kind of little light stems. I like how they have a little light on top. But what I don't like is that they're all the exact same height. And with our Minecraft tree, we actually get the ability to add height rand A and height rand B to choose the height of the trees. So as you can see, this tree is a little bit taller than this tree. That's because we're adding a random height value to each tree. But over here, they're all exactly the same, and that's a little bit boring. So let's go back to VS Code, and in our configured feature for a blue tree, we can see this height of 3. And instead of setting a height to 3, we can actually set this to an integer provider. This has a type, and we'll set this to Minecraft uniform. This gives us min inclusive and max inclusive. Min inclusive is obviously the lowest value that this can be. Let's set this to 2. And the max inclusive, let's set to 4. So now this layer in our block column will be between 2 and 4 blocks high. And then, of course, we will add this height of 1 with our pearlescent frog light on the top. Let's go ahead and check this out. And now our trees are different heights. You can see we've got some that are 2 blocks tall and some that are 4 blocks tall. Now finally, for our yellow forest, my plan is to make the trees a little bit more sparse, but a lot bigger. And to do that inside of our configured feature for yellow tree, we're going to have a type of Minecraft tree, and the trunk placer is actually going to be a type of giant trunk placer. We'll set base height to be 12, and height rand A will be 0, and height rand B will be 6. So now our tree will be anywhere between 12 and 18 blocks tall. And wouldn't it be cool if our tree were made out of yellow glass? Then for our leaves, we'll use the Mega Pine Foliage Placer with a radius of 3. Our crown height will be 3 as well, and our offset will be 0. Now all we need is minimum size. We'll make this 2-layer feature size, and this time we're going to set the lower size to be 2 and the upper size to be 3. That's just because this tree is going to be a little bit bigger than our other trees. We'll give ourselves a dirt provider of yellow glazed terracotta. We'll go ahead and force dirt again and add our empty decorators array. I just realized we forgot our foliage provider. For that, I think we'll use white concrete, and that'll be a nice look with our glass trunk. So now that our tree is all defined, let's go ahead and go to our placed features, add yellow tree. This time we'll have 2 per chunk, and we'll define the same placement rules as before. Now back in Minecraft, now let's add our yellow tree to our yellow forest. And reload our world. And look, we've got these nice yellow trees in our yellow forest with this cool glass look. Our blue trees in our blue forest with the pearlescent frog lights on top. And of course our red trees in our red forest. And I think this makes a pretty cool look for our custom dimension. One thing worth noting is that there are a lot of different feature types that you can use in your configured features. For example, this fallen tree that's new in Minecraft 121.5, this ore, which you can use to add ores underground in your world, and of course the tree. And you can view all of these on the Minecraft wiki, which I'll link down in the description below. But if you expand them, you can see all the configuration options you have for that configured feature type. Anyways, that's going to do it for today. If you enjoyed this video, please leave a like and subscribe if you haven't already. Also, leave a comment letting me know what you think I should add next to our custom dimension. Anyways, thank you for watching, and I'll see you in the next one. Bye-bye.